Good morning, ladies and gentlemen. Let's get you started on today's e-learning assignment. This will be lesson 0 of Unit 6. For the most part, all of the questions on this assignment will be a review. But let's walk you through it so that we have a good handle on what we're asking you to do in this assignment. So this is going to be e-learning. For January 8th, 2017. Keep this for our records. My name is Eddie. So the first thing we have here, we have the following tables give the inputs and outputs of 3 continuous increasing functions. So we have 3 continuous increasing functions. For each set of data, what we want to do is calculate the average rate of change from 5 to 10, from 10 to 15, from 15 to 20, and from 20 to 25. So we're going to have 4 numerical values for each set of data. I have the first set of data, which we're going to call f of x outputs, the second set g of x outputs, and the third set h of x outputs. And I'm just going to get you started here. This is just some arithmetic, basic arithmetic. If I want the average rate of change from x equals 5 to 10 in f, I'm going to look at the output of 10. This is simply the slope of the secant line. This is going to be 8.333 minus 5. This is the f of 5 over 10 minus 5. Now you will want to take your calculator. You can use the calculator on your phone and simplify this number to a single number, a single decimal number. In like manner, you're going to do the same thing from 10 to 15. From 10 to 15 will be 11.6666 minus 8.3333 over 15 minus 10. So I'm going to let you calculate to finish this calculation, and to find these average rate of change right here. And you're going to do the same exact thing for these 2 other functions, g of x and h of x. Just changing up a little bit, you do want the average rate of change in g from 5 to 10, 10 to 15, from 15 to 20, 20 to 15. I will do 15 to 20, get you started on 15 to 20. 15 to 20 is going to be 406.6666 minus 256.6666 over 20 minus 15. And yes, indeed, take your calculator. You can use your graphing calculator. You can use any scientific calculator and reduce that number to a single decimal number. And you're going to do the same from 5 to 10, from 10 to 15, and from 20 to 25. And you're going to do the same thing with h of x outputs. You're going to have 5 numerical values. From 5 to 10, 10 to 15, 15 to 20, and 20 to 15. We have all calculated average rates of change. So this should be a fairly straightforward. And we're going to do this on notebook paper, and this will be due, if you look at the announcement that is associated with this e-learning assignment, this will be due the next time you return to class. Let's look at the next page and see what the next page is asking us to do. So here I want to determine the change in each average rate of change for each function. So if I want this number right here, this number is going to be the change in the average rate of change in f from x equals 5 to x equals 10 to x equals 10 to x equals 15. Let's see where we're going to get those numbers at. What this is going to be, it's going to be the difference in these 2 values. So you're going to simplify this value. You're going to simplify this value. And you're going to see the change, the difference from here to here. So you will take this number and subtract it from this number. That will give you this change here. Where did we go? That's going to give you this number right here. In like manner, if I want to find this number, you want to find the change from this average rate of change to this average rate of change in f of x. Again, to find what that, you're going to take this number, whatever that is that you came up with, and you're going to subtract this guy from this dude. That's why you want to make these a single decimal number. And you're going to do that. You're going to have a number here. Whatever that number is, you're going to have an average rate of change, a single average rate of change. You're going to have a single decimal average rate of change in G from 5 to 10 to 10 to 15. You're going to simplify this to a simple number, a single decimal number. And what the next page is going to ask you for is the difference from this number to this number. So you're going to subtract this from this guy, and you're going to subtract this from this guy. That's going to give you these three, determine the change in each average rate of change for each function. In like manner, you're going to do the same thing with h of x. And you're going to notice some interesting properties in the change in the average rate of change. And that's what you're going to use to describe the average rate of change in each set of data. Be detailed as you possibly can. So you're going to look at the average rate of change in F, and you're going to say something about them. And the reason is going to be given in this table right here. So these reasons, you're going to look up here for the reasons for a description of the average rates of change in F, the average rates of change in G, and the average rates of change in H. And then you're going to determine, you have three sets of data, F, G, and H. One of those sets of data represents a linear function. You're going to determine which one represents a linear function, and you're going to write the rule for that linear function. You can write the rule as a linear function in point-slope form. So one of those will, whatever one is the linear function, you're going to write the rule in point-slope form. And then you're going to, the final question is going to compare the average rate of change in G of x to the average rate of change in H of x. And you want to be as specific as possible. Again, where are you going to get this information? You're going to look at the table above, and that is going to tell you the comparison of these at the average rates of change in G to the average rates of change in H. If you walk through this, do not make this more difficult than it is. It's a fairly straightforward worksheet. The final question we're going to ask you to do, of all the functions are increasing. Determine which function is increasing the fastest and give a valid argument for your statement. Guess where that argument for your valid statement is going to be? It is, yes, indeed, it is going to be in the table on the first part of page 2. That should get you started on this e-learning assignment for January 8th. Do not make it more difficult. It's just calculating some average rates of change and 3 functions, changing y over changing x, changing y over changing x. And then you're going to look at the change, the difference in each average rate of change. You're going to put that in page 2. Let me help you out and let me just do h of x since I have some room here. So if I want from 5 to 10 in h of x, it's going to be 17.758 minus 4.214 over 10 minus 5. Let's take our calculator and see what that comes out to be. That's going to be 13.544 divided by 5. That single number as a decimal is going to be 2.7088. From 15 to 10, it's going to be 74.831 minus 17.758 over 15 minus 5, which is 5. Let's figure out what that number is. 74.831 minus 17.758 divided by 5. That's going to be 11.4146. I will let you do these two yourself. What that next page is asking you for is the difference in these two numbers. So if I want the change in the average rate of change, it's going to be 11.4146 minus 2.7088. And that change, this change is going to be 8.7058. That number goes right here. 8.7058. So that's going to give you a lot of fuel to finish this worksheet. Thank you very much. We'll see you tomorrow. Keep in mind, this is due tomorrow.